Good morning to all. Welcome to my channel, Firjan. Today we discuss electric field. See, electric field due to electric dipole. Due to electric dipole. So this we discuss electric field due to electric dipole. First we discuss electric dipole. See, electric dipole. Electric dipole means two equal and opposite charges which are separated by small distance. We call it as electric dipole. See, for example, Q, one charge, one more Q. It is has opposite charges. One is minus, another one is plus. Two equal and opposite charges which are separated by a distance, small distance. So that is here center. So this distance is L, this distance is L. So means two equal and opposite charges which are separated by a small distance 2L, that is called as electric dipole. Electric dipole means two equal opposite charges separated by small distance is called electric dipole. Two equal means Q and Q and opposite charges minus charge plus charge which are separated by 2L distance, small distance. So that is called as electric dipole. This is the electric dipole, minus Q to Q plus Q. So this is called electric dipole. See, electric dipole moment. Electric dipole moment. Electric dipole moment means it is the product of charge and distance between them. Distance between them is called electric dipole moment. It is the product of charge. Charge means here Q and distance between them. What is the distance between them? 2L. See, it is represented by letter P. Electric dipole is represented by letter P. P equal to charge into distance between them, 2L. Q dot 2L is called electric dipole moment. See, it is vector quantity. Vector quantity. Why it is vector quantity now? See, it has direction. What is the direction of electric dipole now? Minus Q2 plus Q. And what is the magnitude now? Q into 2L. This is the electric dipole moment magnitude. What is the direction now? It is minus Q2 plus Q. This is the direction. It has magnitude and direction. So it is vector quantity. What is the unit now? Unit of this electric dipole moment is, see, unit. Charge na coulomb. Length na meter. Coulomb meter is the unit of electric dipole moment. See, first one, electric dipole means two equal and opposite charges. Two equal and opposite charges separated by a small distance. Separated by small distance. Separated by a small distance is called electric dipole. What now? Minus Q2 plus Q. It is, this is the center. So this length is L, this length is L. Total length is 2L. Means these are separated by 2L length. Its magnitude is here minus Q, here plus Q. See, electric dipole moment means it is the product of charge and distance between them. Product of charge. Charge na Q and distance between them 2L. That is charge and distance between them 2L. So product is called as electric dipole moment. It is vector quantity. Why na? It has magnitude and direction. What is the direction of electric dipole moment? Minus q to plus q. It is unit is coulomb meter. So charge na coulomb, length na meter. Coulomb meter is the unit of electric dipole moment. See this electric dipole. Due to this electric dipole, electric field is produced. So that we discuss. First we discuss electric field due to electric dipole along the axis of the dipole. Along axis of dipole at a distance, at x distance from center along axis, along axis. So that we discuss first. See what is the electric field. See for example here minus q charge plus q which are separated by 2l length. So this is the center. So this length is l, this length is l. See it is the center. From center at x distance, this point, what is the electric field, that we find out now. So means that means electric field at p point along the axis, along the axis of electric dipole from center at x distance, that we want to find out now here. See first we discuss electric field. For example here charge q is there at a p point. What is the electric field now? Electric field equal to kq by distance here r na, kq by r square. This is the electric field due to q charge at p point. What na E equal to kq by r square. Here k means we can write it as 1 by 4 pi epsilon naught q by r square. This is the electric field due to charge q at p point or distance from the charge. See like this, here we find out due to this charge some electric field, due to this charge some electric field at p point. So their net charge, net electric field now we find out now. See due to minus q, what is the charge now? E1 we can write it. See E1 due to this. See what is the distance from here center to this x. This distance is L. So means total distance x plus L. X plus L. See electric field due to minus q charge at p point is here k q by, what is the distance here? X plus L. X plus L whole square. X plus L whole square means electric field due to minus q is at point p is kq by minus kq by x plus L whole square. This is the electric field due to minus q. We can write due to plus q. We can write plus q na this one. So what is the distance here? Center to point na x. This length we subtract na, we get this length. So means x minus L. See distance is from q to p plus q to p x minus L due to that charge. So what is the electric field? That we can write E2. E2 equal to k q by, what is the distance? X minus L. This is x. This total x na from here to here. This length we can subtract. What we get na? X minus L. This length is x minus L. That length we can use here. X minus L whole square. This is the electric field due to plus q at p point. Electric field due to minus q is E1 minus kq by x plus L whole square. See net electric field. See net electric field equal to at point P is E1 plus E2. That E1 is what? Minus kq. I write here minus kq by x plus L whole square. E2 is plus kq by x minus L whole square. So now this is the net electric field at P point due to electric dipole. See now I write E net equal to LCM na x plus L whole square x minus L whole square. I write here x plus L whole square x minus L whole square. See cross multiplication, this and this and this and this. See minus, sorry, kq we can common, what remaining now here? this one we get. So means minus of x minus L whole square plus x plus L whole square. Yes na, see I common kq, here kq is there common, here x minus L whole square minus is there, x plus L whole square plus is there. See now I write here E net equal to what now here kq, see minus of x square plus L square plus sorry minus 2xl. Why? Because now a minus b whole square. Next plus x square plus L square plus 2xl is na, see this one by this one. So a plus b, a minus b means a square minus b square means x square minus L square whole square. See a plus b into a minus b formula is a square minus b square. So we can write x plus L, x minus L, x square minus L square. So that we can use. See next, see here we are getting this E net equal to kq, here minus x square minus L square plus 2xl. Why now we can multiply with minus plus x square plus L square plus 2xl by x square minus L square whole square. Yes na, see minus x square plus x square minus L square plus L square. So 2xl 2xl means 4xl. I write here E net equal to kq 4xl by x square minus L square whole power 2, whole power 2. This we get here. See we can write this one 2 common, 2 we can write separately, 2 into 2q into sorry q into 2l we can write. See kx 2 separately, so means 2 in q into 2l. See I write na 2 2 jar 4, 4xl ql we can get that only. See that we can write separately. So this na by x square minus L square whole square. See here this q into 2l na, what we are getting here q into 2l. So p magnetic moment is electric moment, electric dipole moment is na. So that we can write here. See that equal to 2kx p by x square minus L square whole square. This we are getting E net. Yes na, see again from here E net equal to what, E1 plus E2, E net equal to E1 what, minus kq by x plus L whole square plus kq by x minus L whole square. See E net kq common, here this one here multiplied, this one here multiplied, x minus L whole square minus of plus x plus L whole square. So a minus b whole square, a square plus b square minus 2ab, a square plus b square plus 2ab. So minus multiplied, minus x square minus L square minus L minus plus 2xl. So same x square plus L square plus 2xl, x square cancel, L square cancel, 2xl 2xl 4xl. Here kq is there, kq 4xl. This 4xl can be write it as 2kx into q into 2l we can write. See x square minus L square. Why we are writing now this one, q into 2l is electric dipole moment. So that's why 2kxp by x square minus L square whole square. Now see here we get E net equal to E net equal to what not 2kp 2x kxp by x square minus L square whole square we are getting. Now see L is very very small to x, that time L square tend to 0. So means where L square is there we can write 0. So what we get E net equal to 2kxp by x square whole square. Why na minus 0 na, so x square whole square. So means here 2kxp by x square whole square na x power 4, 1x cancel, what we get x cube. So means E net equal to 2kp by x cube. This is the net electric field due to electric dipole along the axis from the center at x distance. X distance from the center. This is the electric dipole, sorry, electric field due to electric dipole. E net equal to what? Along the axis of dipole 2 kp by x cube. Okay, na? Now we discuss electric dipole moment, electric field due to electric dipole equatorial along the equatorial line. See, for example, here see, this is minus q plus q, which are separated by L distance. See, this is the center, this length is L, this length is L, total is 2L. Now we are placing, see, at point P, this point, what is the electric field that we want to find out now. See, due to this minus q, electric field is there at P, that is towards minus q. Yes, na? In the same way, here plus q, due to this plus q, it is away from the plus q. So this one, see here, it makes angle theta here, it makes angle theta here. See, this is E1, this is E2. See, it has, see here theta na, this is the resultant. Yes na, see, E1 E2 resultant is that one. See here theta, here also theta, here theta na, here also theta. Why na? These are corresponding angles, these are alternate interior angles. See, for example, this we can first see, this and this parallel, this line parallel. See, it is the transversal, this angle equal. Why? Because alternate interior angles. See, for example, this line you take, this is parallel to this line, so this is and these are corresponding angles. So this angle is here, same, this angle same. Now see here, this E1 has two component. One is this theta, which side is it? That is E1 cos theta, this side E1 sin theta. Yes, na? This component is E1 cos theta, this component is E1 sin theta. Now see, this also E2 has two components. One is this one, E2 cos theta, this side is E1, E2 sin theta. This is the two components. See here, for this is under equal, it has two components. One is E1 cos theta along vertical, E1 sin theta. For this E2 cos theta, this side E2 sin theta. Here we get two components. See, this one downwards is upwards. To cancel, we will have only E1 cos theta, E2 cos theta. What is the E net now? E net equal to E1 plus E2. This one, due to this, see here, due to this is E2 cos theta, due to this is E1 cos theta. Both na same magnitude. Why na? Here E1 equal to KQ by R square. This distance is R. This X, this L, this R. This also R distance. See, this one is E2 is KQ by R square only. So that's why E1 equal to E2 na. We can take here E net equal to 2E cos theta. We can write. Why na? E1 is E1 cos theta, E2 is E2 cos theta. E1 is E cos theta. I write here E cos theta plus E cos theta. What we get now here? 2E cos theta. So means E means what? KQ by X square. Sorry, KQ by R square. See, cos theta, we can write it. Yes, na? See, E means KQ by R square. 2 like that, E KQ by R square, cos theta like that. See, cos theta equal to, from this we can write, see, cos theta, opposite, adjacent, hypotenuse. Adjacent by hypotenuse is cos theta, means L by R we can write. Here instead of cos theta we can write L by R. We can write here 2 KQ L by R square into R. What na? R power 3 we get. So means 2 KQL by R cube. This is the electric field due to electric dipole perpendicular to electric dipole. Perpendicular to means that perpendicular line, that you call it as equatorial line. So means the line which is perpendicular to electric dipole and passes through center, that is called equatorial line. Passes through center along axis is called axial line. See here equatorial line na, on equatorial line what is the electric field na, 2 kql by r cube. Here r equal to, see here it is l, it is x distance. So means r equal to root of x square plus l square. Yes, it is right angle triangle. That's why. See r equal to what? X square plus l square root of. Instead of that we can write 2kql by r cube means x square plus r square whole power 1 by 2 into 3. Yes, now why not? Here cube is there. So what we can write? 2kql by x square plus r square whole power 3 by 2. Whole power 3 by 2. See, if r is, sorry, here x square plus, not no, r square, l square. L is very small to x, then l square tends to 0. Here also same condition we can take. See, 2, here we can write k q 2l by x square whole power 3 by 2. This 2 cancel. What we get? K q into 2l na, dipole moment. So that's why electric dipole moment kp by x cube. This is the net electric field due to electric dipole on equatorial line. Equatorial line. What is the electric field na? Electric field equal to, on equatorial line, kp by x cube. This is the electric field due to electric dipole on equatorial line. This is the electric field due to electric dipole on axial line. Yes, na? So this one, see again once, this is the electric dipole, this is the equatorial line. Equatorial line means the line which is perpendicular to electric dipole and passes through axis center. So that is called equatorial line. At equatorial line, x distance from the center P point, what is the electric field that we find out. Due to this point, E1 cos theta electric field, due to this point E2 cos theta. Why not here? See, it has electric field this side. So means here this theta, here also theta. Why? Because these two are alternate interior angles. It has two components. One is along horizontal line E1 cos theta, vertical line E1 sin theta. For this and this angle are equal. Why? Because these two are corresponding angles. This and this corresponding angles. So that case it has two components, E2 cos theta, E2 sin theta. E1 sin theta, E2 sin theta cancel. What we have? E1 cos theta, E2 sin, E2 cos theta. So E1, E2 are same magnitude. So we can write E cos theta, E cos theta, 2E cos theta. 2E means kq by r square. See, cos theta na here adjacent by hypotenuse. What na? L by r. So that we can write here 2kq by r square into L by R. So means 2kql by R cube. So R means this is the value. We can substitute here 2kql by x square plus R square whole power 1 by 2, 3. So we can write 3 into 1, 3 by 2. So x square plus L square 3 by 2. 2kql by x square plus L square whole power 3 by 2. If L is very small to x, that case L square tends to 0. This L square is 0. X square 3 by 2, 2 cancel, 2 KQL now here K, this 2Q 2L we can write. Why now Q into 2L is electric dipole moment. So KP we can write by X cube. 2 KP by X cube means electric field on equatorial line, X distance from the center is Kp by X cube. On axial line, X distance from the center is 2 Kp by X cube. Thank you. Now see electric field due to electric dipole. Electric dipole at any point on space, at any point on space, that, see how to this one, see, at the equatorial point na, what is the electric field? Kp by x cube. At axial point na, ea equal to 2 kp by x cube. Equatorial point na, see, kp by x cube. This is the electric field due to electric dipole on axial line. This is the electric field due to electric dipole on equatorial line, x distance, 2 kp by x cube, kp by x cube. Now we find out electric field due to electric dipole at any point on space. For example, see, this is minus q plus q. Yes, now this is the electric dipole at any point, this point for example, or this point, this point, this point. So whatever. See this case, pole we can write x comma theta. Here x means, x is the distance from center. X means here is the distance from center. From center, x distance. This point, what is the electric field due to this electric dipole, that we find out. See, theta is the angle made from direction of dipole moment, or dipole, electric dipole. See here, this one, this, see, it makes a theta angle. This point, what is the electric field, that we find out. For that we have two components is there. See, one is this one, this dipole moment is p na. See, this is p cos theta, this one is p sin theta, p sin theta. See, in this case, this is, we have two dipoles is there. One is p cos theta, another one is p sin theta. Because of the, we have two dipoles, two dipoles. One is p cos theta, p cos theta. M is axial point. Here this point p is axial point. P sin theta, M is equatorial point. Equatorial point. See, this one moment is, dipole moment is p sin theta. Here this is p cos theta. This momentum, see na, at axial point. This is axial point, means along axis. This, for this it is equatorial. It is equatorial. So this case, what is the p cos theta? What is the electric field na? Means axial point. Means we can write 2 kp cos theta by x cube. We can write, why na, x distance. Yes na, 2 kp cos theta by x cube. Axial point. See, this is axial point, means along the dipole. This dipole, it is perpendicular. See, that's why p sin theta. See, for p sin theta, electric field is equatorial point. See, for this it is equatorial point at x distance, x distance. So that case, what is the electric field now here? Equal to kp sin theta by x cube. This is the axial point, it is the equatorial point. P cos theta is one electric dipole, p sin theta is one electric dipole. We have two electric dipoles. One is p cos theta, another one is p sin theta. See, at p point, see, this is axial point, it is equatorial point. Yes na, this is equatorial point. So this case, p cos theta axial point na. So what is the electric field? 2 kp by x cube. Actually p means what here? P cos theta. Moment is dipole, electric dipole moment is p cos theta. So this electric dipole what na moment uh, along axial point, this is along equatorial point. See, so ea equal to 2 kp by cos theta by x cube, p sin theta for this dipole equatorial point na, it will be act as equatorial point, kp sin theta by x cube. This case we find out what is the net electric field for finding at any point. So this point, any point we can find out electric dipole electric field. So for that what now, see here, see E net I write here, E net equal to, see, EA plus E equatorial. Yes na? See, vector quantity na this one. See, this electric field is vector quantity. This now what is the angle now here? 90 total. So that case, see what na E net equal to what we can write na, root of actually resultant vector na, resultant vector what na, a square plus b square plus 2ab cos theta. Cos theta is what here? 90. So that case a square plus b square only resultant. So we can write here what na, this one ea square means 2 kp cos theta by x cube whole square, yes, plus this one equatorial point 2 kp sin theta by x cube whole square. Here see 2 kp by x cube, kp by x cube common na? So both cases kp by x cube, what we have here 2 cos theta whole square plus sin theta whole square. What we get here finally, see, in this kp by x cube 2 cos theta whole square na, 4 cos square theta plus sin square theta. This can be write it as kp by x cube. 4 cos theta we can write 3 cos square theta plus cos square theta plus sin square, like that only we can write here. See, this cos square theta plus sin square theta is 1. So we can write here kp by x cube here 1 plus 3 cos square theta. So this is the net electric field due to electric dipole at any point in the space. This point theta angle, this point theta, so means angle, so means it will be anti-clockwise direction. So means why now we can measure from here to only. See, this is the direction of moment. So angle is from where we are taking, theta is the angle made from direction of dipole moment. So this is the direction of dipole moment, this case is theta. For example here we can, they gave now we can take this angle. So means for example like this they will give, it is for example 120 they give, we can take theta is what, 60 only. Why not? It will be anti-clockwise, in the direction of dipole moment only we can take angle. So that case at any point in the space, this point, this point, or this point, this point, so we can find out the electric field. So for that formula is E net equal to kp by x cube into root of 1 plus 3 cos square theta. For example, if see, if theta equal to 0 we can write what we get now, E net equal to, see, kp by x cube. What is theta value? 0. Cos 0 1, so means 1 plus 3 root of 1 plus 3 means what we get 2 only, 2 kp by x cube. What theta equal to 0 means what, it is minus q plus q. This is the direction of dipole moment at x distance. So means what we get, axial point, axial point what is the electric field, 2 kp by x cube na. So we are getting, for example theta equal to 90 we can take, means equatorial point. See, theta equal to 90, what is the formula here, kp by x cube. See, E electric field due to electric dipole at theta equal to 90, kp by x cube root of 1 plus 3 cos 90, cos 90 0. So what we get, kp by x cube. What is the electric field along on equatorial point? Kp by x cube. So we are getting. So this is the general formula for finding at any point on the space electric field due to electric dipole. That is formula is E net equal to Kp by x cube root of 1 plus 3 cos square theta. Okay, thank you.